Harry Potter has a cloak of invisibility. So can scientists really make such a cloak? Now, before I tell the story, I want to emphasize that invisibility is not the same as stealth. Now, stealth technology has been around for quite some time. A stealth object either absorbs or deflects radar away from the sensor, so the sensor cannot detect the object by radar. So a stealth object is in fact a dark object. It is not invisible. By invisibility, what we mean is perfect transparency, as we have seen in many movies. Now, I can assure you that perfect transparency is much, much more difficult to realize than stealth. Now, in the last century, science writers have the vision that maybe one day a man can drink some chemicals and transform them to become invisible. Now, such chemicals doesn't exist. Even if they do, I would suggest that you don't try that, because modifying your body chemically is very dangerous, and by drinking something, you cannot make your clothes go away. Now, in more modern concepts, there is a lady, superhero called the Invisible Woman. Now, she is way smarter than the Invisible Man. She doesn't try to drink something. Well, what she tries to do is to create a force field to guide light around herself so that you cannot see her. Now, the question is, can scientists really make something that can make light go around a body so that you cannot see that body? So can light travel in a curve in the first place? Now, the answer is yes, it is. There is a natural phenomenon called mirage, which indeed light do travel in a curve due to thermal gradient of air, and that creates an optical illusion. In the year 2006, British scientists invented a new method called transformation optics. And with that method, they designed invisibility cloaks, which really can guide light around an object so that you do not see that object. Now, technically speaking, you can say that that is, in fact, a mirage effect. Or you can say that they have achieved what the Invisible Woman wanted to do. Now, this is regarded as a very major breakthrough in science. However, there's no free lunch. It turns out that nothing in nature can do the job. You have to make those materials by yourself using really advanced technology. But if you can do that, the same idea can actually allow us to design not only cloaks for light, but also cloaks for other kinds of waves, such as sound wave, heat wave, and even seismic wave. Now, these are some examples that are made in Europe and United States that can cloak sound waves. Now, but that is not the end of the story. Now, it turns out that for the invisibility cloak that was designed, what it works is by excluding light from a region. Now, so that the object or the body being cloaked inside the cloak is totally blinded by the cloak. What it means is that if Harry Potter have this kind of cloak, then you cannot see him, but he sees nothing. Okay. Now, in order to get around that problem, we in Hong Kong invented another way. What we do is that we design what we call an anti-object, and we use that anti-object to cancel the light scattered by an object. It is like 1 + -1 = 0, so that an outside viewer cannot see the object and you cannot see the anti-object. So the object becomes nothing. Okay, now, but you see that, well, okay, you have done that, but is invisibility just one form of illusion? Can we go one step further? For example, can I make an apple look like a banana? Well, the answer is yes. Let me show you an example that we have done. So in the next slide, you're going to see that on the left-hand side, I'm going to show you the scattering pattern of a spoon. And on the right-hand side, and you've seen it now, you see the scattering pattern of a cup. Now, in the middle, I designed something, which is a material. When it put next to the spoon, actually it makes the spoon look like a cup for someone far away, so that you do not see that cloak, you do not see the spoon, but instead you see a cup instead. Now, but up to now, all the design we have, we use what we call passive materials. If you allow me to use power and energy, I can also design active sources which can emit waves that can transform one object to make it look like another. Say, for example, I can make, the example shows I can make an apple look like a banana. So, as a summary, I would say that in the past, it is chemists who made most of the materials. Right now, physicists can also use computers to design new materials according to laws of nature. And some of these materials may help us to go one step closer to the technologies that you used to see in science fiction. And thank you.